So, guys, welcome back to the shop. Today we are doing something a bit different. We're playing with mains electricity, which is always a fun thing. What I've set up here is, it comes from the fact that I recently bought these LED replacement tubes, and they basically fit into your lighting fixture like this one over here, without any modifications except the starter. And then some guy told me that, yeah, but you should remove the condenser. And then when you look at the instructions, you can actually also remove the choke as well. So I started thinking, like, what is actually worth doing? Because removing the condenser, a bit of a pain. You have to pull the cover and you have to know what you're doing, kind of, sort of. But it's still not, you know, hard. Removing that one requires a bit of fiddling around inside the fixture and stuff like that. So what we're going to do today is we're going to test our setup and see how much savings, or how much can you actually save by then just changing starter, removing the condenser, capacitor, and also removing the choke. So yeah, I'll get started here and fit a normal lighting tube, and we have this setup over here, which is, I know, looks a bit sketchy, but it's basically a ground fault current interrupter, residual current device, something. Protects you if you short things to earth. Then we have a circuit breaker, and then we have a Chinese special power factor meter, which we can see though then how much the device draws and how much what's basically going on. We have cos phi, the angle, watts and volt amperes. So I'm gonna get set up here and fetch a normal fluorescent tube, if you give me a moment. So what we're going to do is we're going to get a brand new Philips tube. And I don't know why I'm doing this so gingerly. I have no power up at all, but it's always good to assume that you're going to get electrocuted. Now when we turn it on, it lights. And hopefully you might be able to see that our measurement is reading 56 watts at half an amp mains voltage, but we're actually pulling 127 volt amperes, which translates into quite shoddy power factor at 0.45 maybe. So that's not very nice now, is it? So we're actually pulling, the reactive power is around half. Yes. So since the power factor is less than half, we're actually pulling 120 volt amperes from the grid, but we're actually only using 50 watts. I'm not an electrical engineer, I have no idea, but I know you want those numbers as close to each other, or the power factor as close to 1 as possible. So now then, what we're going to do now is remove this tube. Try not to break it. And yeah, and what we're going to do now is fetch a Philips LED tube. So this is a, there goes the starter. Yeah, so this is a, I don't know if you can read, but it's a Philips Core Pro LED tube. Yeah, whatever. So we're going to try to get it out of its packaging. This one, the other one was labeled at 46, no, 36 is the nominal wattage of a normal tube. These ones are 16, so that's not too shabby. 16 watts, and I think these are cool white, so 4000 Kelvin maybe. But so what we're going to do is we're going to first take out the starter, and then we're going to insert the modified starter, which I am fairly sure is just a dead short. It might also be something a little more exciting, maybe a small fuse or something. So there we have, and these are EM mains tubes, so they run at full line voltage. So we haven't done any modifications to the fixture except changing the starter, and this is what the manufacturer recommends in the literature if we would have bothered to read whatever that came with it. So this is what you have to do. You have to change the starter. And now we're going to contact. And this is a complete failure. So my stuff is a bit, you know, should we say pre-used. So we have a broken socket. So let's not fiddle with that too much, but we have, as you can see, an equally bright tube. So what we're going to do now is we're going to, and as you can see, it's drawing 0.06 amperes and 15 watts. And quite astonishingly 16 volt amperes. So we have a cos phi of 0.94. We're doing with such low current here, I would actually need a bank with more of these to test it. But so basically we're fucked, okay? Because the whole point was to show that actually we're doing these modifications. Well, we have already basically proven that all you need to do is change the starter. But I'm not sure, but I'm fairly certain this should be almost a perfectly resistive load, and we are not quite there yet. So what I'm going to do is I'm going to solder on, and we'll see what happens when we remove, because you would want to remove this thing that's from the 70s, and these usually are things that burn up, so it can't be bad to change them out. But we're going to try, at least. So now you're going to get to watch a montage of me removing the condenser, then we'll get back to our regularly scheduled programming. Well, welcome back again. Now I have finally managed to remove the choke. Oh no, the capacitor. This nasty little bugger. So, and I've also changed the fixture because the other one was having problems. So now let's test it without the capacitor. As we can see, it lights up beautifully. And it draws almost nothing, 15 watts, but 15.1 watts, 15.8 volt amps. So we're getting a bit, not purely, but we're much closer to 95, 96 instead of 93 we were around. So it does something. And now we're going to do what I've been waiting to do, which is get rid of this whole honking choke. Because these are what blows up, and I just got zapped by one, so I'm a bit vindictive at this point. And it also says here it has a cos phi. a power factor of 0.5. So it wasn't that far off with 0.45, considering this one is probably from the 70s. So what we're going to do now is we're going to chuck that off. We're going to remove the tube, if I can manage. Yes. This one is a bit more tight. We're going to put that one gingerly, because these are actually, this model is actually glass. Now we're going to unplug that so we don't have a live ground. Go into the circuit, and we're just going to yank this hair wire, if we can manage. Yes. Yeah, my meter is beeping at me. So we're going to yank that wire. And we're going to get in there. We're going to yank that wire. Okay, so now the choke is completely isolated, but I'm going to very carefully avoid touching anything, since I just got, yeah. I'm not sure if you're going to be hearing any of this. This might be a montage quite quickly, depending on how a bugger this one is to get out of here. Yeah, bent sheet metal, hallelujah. Yeah. I think we're going to do an ever so slight modification, since we won't be needing anything of this. I suggest you don't try this while standing on the top of a 10-foot ladder. Yes. And this one is probably charged, because quite frankly I'm not too keen on getting zapped again. So, we have since removed the choke. One moment, well, we might actually study the tubes. So, we should be able to, yes, here we are. I'll try and see if I can find a better picture of this. Basically what you do is you remove the high frequency ballast and you wire it to receive, yes, so one side is getting the neutral, and it goes all the way and into the solder. And this one comes back from the starter and goes all the way to the other end. So we're just going to join the face to that other wire. Moment please. We're going to get a small Vago. Check that everything's tight. So we have now removed everything from this fixture, and this one is basically just shorting that, so we get a nice back feed for our tube. So we're going to plug that back in, and we're going to take the tube back in here. Ah, you bugger. Get in there. Yeah. So, there we are. Ooh, hoo, 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 hoo. That's a crunchy one. Yes. So, contact lights up instantly. And now, we are actually down to 14.4 watts, 15.5 VA, and a worse cost 5. So the choke actually consumes around 3 watts of power, but it compensates somehow. because the choke is basically just like half the winding of transformer, so it actually feeds through. But okay. So basically, my thoughts on this is don't bother at all. Just put in the new starter which shorts the condenser and leave all that crap and save yourself from getting electrocuted. Yeah, but there you have it. It's not worth your time to remove the condenser, the capacitor. Sorry, in Swedish it's close to condenser, so it's same word for capacitor and condenser in Swedish. Yeah, so the capacitor and choke. If you have it like the table, you might as well remove it, because let's face it, these things are not eternal, so you might as well remove it while you're at it. But do it on the table with nothing plugged in like an idiot like myself. Yeah, so I think that's the gist of it. I'm not quite sure. This one is probably going to get recycled, and the whole fitting that bit me. And yeah, but this was it. Don't bother, just change the starter, you'll be fine. Yeah, thank you for watching, and hope you have a nice weekend.